Hey guys, go ahead and make this big. All right, so today we're going to be talking about domain and range word problems. First, we're going to start with discrete. So remember discrete, and then we also have continuous. Discrete, remember, is just individual points. It does not have the line that connects all the points. Okay, so we're going to start with discrete, which means individual points. Okay, so let's read the problem, but then I want to talk about cubes, which is what we're going to be using to help us break down word problems. So I'm going to write cubes right here. Okay, first let's read it in its totality real quick. The total cost in dollars to buy uniforms for the soccer team players can be found using the function y equals 28.95x plus 4.25, where x is the number of uniforms purchased. There is a minimum of 16 players and a maximum of 20 players on the team. What is the domain of the function for this situation, and what is the range for this situation? Okay, so our C is going to stand for circle the key numbers. So I see 16 and 20, those are my key numbers. We need to underline the question, so U stands for underline the question. So what is the domain? What is the range? B is going to be box any math action words and write the operation symbol. Well, I don't really see any of those, so I'll skip B. We're going to use E, eliminate and get rid of unnecessary information. It's all pretty important. We need to know all of that. And then S, we're going to solve and check our work. Okay, so from here, let me explain why this is discrete and not continuous. Okay, in this situation, we're talking about uniforms and cost, all right? So let's go ahead and highlight those words as well. And I know that this is discrete because I know I can't buy 1.2 uniforms, okay? They can only be individual. So that's why I know that this is not continuous. It has to be discrete. I can buy one uniform, I can buy 5 uniforms, but I can't buy 2.3. So it's not going to be continuous. Okay, so domain in this situation, we know is x's. So let's read the story and figure out what x stands for. Well, I know it tells me that x is the number of uniforms. Okay, so let's talk about how many uniforms we're going to buy in this situation. Well, it tells me that there is a minimum of 16 players and a maximum of 20 players. Well, you only buy a uniform for the number of players that you have. Well, we're going to have a minimum of 16 players. Remember, minimum is the lowest amount. So I know the lowest number of uniforms I can have is 16. It tells me the maximum number of players I can have is 20, so that's going to be the maximum number of uniforms. So 16 through 20. It could be any of them from 16 all the way through 20, so I'm going to list all of those. So we could buy 16, 17, 18, 19, or 20 uniforms. Okay, so we answered this question. What is the domain? We did that. I know domain is x. It told me x was the number of uniforms. Well, I know we could have anywhere from 16 to 20 players. So I could have 16, 17, 18, 19, or 20 uniforms. Okay, now let's do range. We know range is y. And we know that y is standing for the cost. So now we have to figure out what would it cost if we bought 16 uniforms, 17 uniforms, 18, 19, and 20. So the way I'm going to do that is I'm going to graph this equation that it gave me. And then I'm going to use a table to look at the y values for each of these x values. All right, so the equation it gave me is 28.95x plus 4.25. All right, now that I have it graphed, I'm going to open the table. Well, remember, table starts with the letter T, so I'm going to press Control T. This first row, or this first column, I mean, and these are your X values. The second one, this is your Y values. Okay, so my X values, I know the lowest number of uniforms we're going to have is 16, so let's go to 16. So if I bought 16 uniforms, I know it's going to cost me $467.45. So I'm going to write that value down first. Here, that way y'all can see both. Okay, so if we bought 16 uniforms, that's what it's going to cost. So, okay, so now we have to continue and mark down what it would cost for 17, 18, 19, and 20. So I'm going to scroll down. That's what it costs for 16, 17, 18, 19, and 20 uniforms. So I'm going to separate those with a comma and write these numbers down. Sorry, excuse my brackets. So one more time, we know domain was X, which was talking about uniforms. Well, I can have anywhere from 16 to 20 players, so that's how many uniforms I could possibly buy, anywhere from 16 to 20 uniforms. So that's why 16, 17, 18, 19, 20. My range is my Y, which was talking about the cost of those uniforms. So I had to write down what it would cost me if I bought 16 uniforms, 17 uniforms, 18, 19, and 20, the cost of each of those. And then how we got the cost one more time is we graphed our equation and then we opened our table. And we went down to where X was 16 through 20 and wrote those values of our Y down. All right, let's try another example. Let's read it first. It says, the final cost in dollars to buy robotic kits for the science club can be found using the function C equals 49.85N plus 7.95, where N is the number of kits purchased. They want to purchase at least 8 kits, but not more than 12 kits. What is the domain of this function, and what is the range of this function? So first, for cubes C, we need to circle the key numbers. I'm actually going to circle at least 8, not more than 12. Let's underline the question. What is the domain? What is the range? B, box math action words, as in plus, minus, multiply, divide. I don't really see any of those. E, eliminate unnecessary information, which we pretty much need everything. Okay, now we're going to solve and check. Okay, so the question is asking for domain, so that's where we need to start. We know that domain is X. Okay, but here's the thing, they don't use an X in this situation. All right, so I know either they're using a C or N to represent X. Well, how do I know which one's which? Well, we know our equations are always Y equals, so this guy is our Y, this guy is our X, so you might want to label that. So we know our X is N in this case, and it tells me that N is the number of kits. Okay, so I know that this one is also discrete, not continuous, because if we're talking about the number of kits we're gonna buy, I know I can buy 5 kits, but I can't buy 5.1 kits. It's just not possible. That's why this one is discrete and not continuous. All right, so let's talk about how many kits we're gonna buy. It tells us they want to purchase at least 8, so minimum of 8, but I don't want to buy more than 12. So let's list all of our options. So the lowest number we can buy is 8. The highest we can buy is 12, so I'm going to list every number from 8 to 12. Okay, so that's all my possible options for the number of kits I can buy. So we can buy 8 kits, 9 kits, 10, 11, or 12 kits. All right, so let's answer the second question, our range. Range, which is y. Remember, they don't use a y in this case, but y equals, so in this case they're using c instead of our y. And we know that c stands for the final cost. So now our job is to figure out if we buy 8 kits, what would that cost be? If we bought 9 kits, what would that cost be? And so on and so forth. So in order to find our y, what I'm going to do is I'm going to graph this equation that they gave us, and I'm going to open my table. So new document, never save. Okay, so I'm going to graph 49.85. They say in, but you can't type in into a graph. So what we're going to do is we're going to type in x instead. So 49.85x plus 7.95. So 49.85x plus 7.95. Okay, now that we have it graphed, we're going to open our table so I can find the y values that match these x values. So Control T. All right, your first column are your x's, so these are talking about the number of kits we're buying. The second column is your y's, so these numbers are talking about the cost. All right, so we know the lowest number of kits we can buy is 8, so I'm going to go down to 8 kits. Uh-oh. My bad. 8 kits. So if we bought 8 kits, I know it would cost us $406.75. So I'm going to go ahead and write that down. Oh, I'm so awful at brackets. Okay, but we're not done until we find all of these different costs. So now let's go to 9 kits. If we buy 9 kits, it costs $456.6. 10 kits, $11 kits, I have to shrink this real quick. I'm running out of room. And finally, 12 kits. All right. So there we have it, our domain, number of kits that we might buy. Well, we had at least 8, but no more than 12, so I could have bought anywhere from 8 to 12 kits. So that's our domain. Range represents the cost, so then I had to write down the cost if we would have bought each of those numbers of kits. Okay, Tanya is charging her siblings to wrap their Christmas gifts for them. The function f of x equals 3x represents the amount of money in dollars she will earn for wrapping x presents. She only has enough wrapping paper to wrap 7 gifts. What is the domain and range for this problem? Okay, so cube, C, circle the key numbers. She only has enough to wrap 7 gifts. Underline the question, what is the domain and range? Box any math action words. I don't see any of those. And then eliminate any extra information. We seem to need all of this, so now we're going to S, solve and check. Okay, domain and range. So let's answer domain first. Well, we know domain is X. And X in this situation tells us, stands for presence. Okay, so let's explain why this one is discrete as well. I know that this one is discrete, not continuous. It has to be discrete because you can't wrap 7.3 presents. You wrap the entire present. So I can wrap 1 present, 2 presents, 3. You never say, oh, I wrapped 3.25 presents, okay? So this one has to be discrete. So what we're going to do is we're going to list the number of presents that she can wrap. Okay, well, one thing that's going to limit us here is it says she only has enough wrapping paper to wrap 7 gifts. So I know the most that she can wrap is 7. So it's possible that she wraps none. What if her sisters or her siblings don't want to use her? So that she could wrap none. And she can wrap all the way up to 7. So I'm going to list all numbers up to 7. So 0, 1, 2, 3, 4, 5, 6, 7. All right, so that's our possibilities. Those are all the possible number of presents that she can possibly wrap. She can wrap 0 if her siblings don't want her to wrap their presents. And she can wrap up to 7 and use all of her wrapping paper and anything in between. All right, now let's talk about range, which is our Y. Remember, this guy means Y. And I know her Y is talking about how much money will she earn. So I know she's going to earn money for each gift that she wraps. So to figure out how much money she's going to earn, I'm going to go graph this equation that it gave me and use my table. All right, so the equation it gave me was 3x. I'm going to graph that. Now I'm going to open my table, Control T. I know the smallest number of gifts that she can wrap is 0. So remember these x's, that's talking about the number of presents. This y, these numbers are talking about how much money she will earn. So the lowest number she can wrap is 0. So if she wraps 0 presents, she's going to make $0. We need to go all the way through 7. So if she wraps 1 present, she's going to make $3. 2 presents is 6. 3 presents, she'd make $9. 4 presents, she would make 12. All right, we're almost there. Remember, we're going up to 7. 5 presents, she would make 15. 6, she would earn 18. And if she does all 7, she would earn $21. All right, now let's jump into some continuous problems. Okay, and I'll explain why they're continuous here in a second. So let's read it first. When driving for Uber, there is a base fare of $2, which is a flat fee you are charged at the beginning of the ride. Suppose the function p of x equals 0.40x plus 2 represents the price of an Uber ride where x is the number of miles driven. Find the domain and the range for up to 10 miles. Okay, so on this one, we're going to start with C. We're going to circle the key numbers. So I know that there's a base fare of $2. I know that we're going to do this for only up to 10 miles. We're going to underline the question. We're going to find the domain and range for up to 10 miles. We're going to box any math action words. Don't see any of that. Eliminate any information we don't need. We pretty much need all of it. And then, so now we're going to solve and check. All right, first let's find the domain. Which we know is x. And in this story, it told us x stands for number of miles. Okay, so let me explain why I know that this one is a continuous problem. So like in the last example, I know we couldn't buy 1.2 kits or 1.2 uniforms. Okay, but in this case, we're talking about miles, and it is possible to drive 1.2 miles. A part of a mile is possible. So that's why I know this is continuous. This one would be a graph with a continuing line. Okay, so we write domain and range differently if it's continuous. Okay, so the number of miles, the key piece of information that we know about it is it's going to go up to 10 miles. So the way we're going to write this is the farthest we can go is 10. And the lowest number of miles you could possibly drive is 0. So 0 to 10. I'm going to leave it blank in between for now. Okay, so since it's domain, I want to stick an X in the middle. Remember, you always do the small number to the big number. So because you start small to big, you're going to want to put two less than symbols. So what this is pretty much saying is your X is between 0 and 10. Okay, now we have to decide, do I put or equals underneath? Well, can you possibly drive 0 miles? Yes, you can go nowhere. Someone put or equals. Is it possible to drive the full 10 miles exactly? Yes, someone put the or equals. So I know how many miles we're going to drive is anywhere between or equal to 0 and 10. So I could drive 5.3 miles. I can drive 1 mile, anywhere from 0 to 10. All right, now let's talk about range. So we know that range is y. And in this case, we know that our y will be the price. How much is it going to cost us? So depending on how far we go, it's going to depend on what our price is. So what I'm going to do is I'm going to use this same equation. I'm going to type it in and I'm going to go to my table. So the equation it gave me is 0.40x plus 2. And that's what it looks like. And I'm going to press Control T. Okay, so on this situation, the cost is going to fluctuate from the smallest amount that we could possibly drive to the highest amount. So that's what we need to look at. So the lowest it's going to cost me is if I go 0 miles. So I'm going to go find where x is 0. So when x is 0, it's going to cost me 2 miles because remember that's your base fare. So I know the lowest it could possibly cost is 2. Okay, now what I need to do is go find the highest it's going to cost me. Well, the highest it will cost me if I go the full 10-mile distance. So now I'm going to go to where x is 10. So that's the farthest I can travel, which means the highest I can pay is 6. So I put my 2 and my 6. Since it's range, I'm going to put a y between. Since we always put the small number to the large number, we're going to put two less than symbols. So that's pretty much saying between. All right, now let's decide if it could be exactly equal. All right, so like we said, it could equal 0 miles. That's if you sit in the cab and then hop back out. Why would you do that? I don't know, but you could. So yes, it could exactly equal 2. Or you can go the full exact 10 miles, so it could cost you exactly $6. So the domain is talking about the possible number of miles we could take the cab or the Uber. And the range is talking about my price range. And it's going to cost me anywhere from $2 to $6, depending on how far I take it. Okay, 5. A bicycle rental shop rents bicycles for $8 per hour. The total cost C in dollars for renting a bicycle H hours is given by the function C equals 8H. Once you get to the rental shop, you figure you can rent a bicycle for at most 5 hours. What is the domain and range for this situation? So cube, C, circle the key numbers. Okay, so I know we can do it for $8 per hour, and I know that we're gonna rent it for at most 5 hours. So that means the longest we're gonna have it for is 5 hours. Okay, you underline the question. What is the domain and the range? B, box any math action words. Well, one action word I see right here is per, which means multiply. That's where this comes from. 8 per hour. So 8 multiplied by the hours. That's where this equation comes from. 8 times H. 8 times the number of hours. Eliminate any unnecessary information. I believe we need all of this. And S, let's solve and check. All right, so let's talk about domain first. Domain is X. Well, in the story, they don't use an X. So we have to figure out which one of these is X, which one of these is Y. Well, remember, it's always Y equals. So C is Y, H is X. Well, we know that H stands for hours. All right, real quick, let's talk about why this one is continuous, because X is hours. So it is possible to have a part of an hour, which is why it's continuous. I can have 1.3 hours. All right, so that's how I know that this one is continuous. Okay, so we want to talk about the lowest number of hours and the highest number of hours we could have this bike. Well, the lowest number of hours we can rent the bike for is 0 hours. Now let's talk about the highest number of hours we can rent it. Well, it tells me I can rent it for at most 5 hours. So the lowest is 0, the highest is 5. I know it's domain, so I'm going to put H in the middle because H is representing our X. And we're going to put 2 less than symbols. Okay, now we have to decide, do we put the or equal? Well, exactly 0 hours is possible and exactly 5 hours is possible. So I put the or equals. All right, now let's talk about range. We know range is Y, and we said that they use C instead of Y. So it tells me that C is going to stand for the total cost. So now that we know the low number of hours and the high number of hours, we need to find a low cost and a high cost. And we're going to do that by graphing our equation and using the table. Okay, the equation says 8H. Well, I can't type H, so I'm going to write 8X. And then I'm going to open my table, Control T. All right, so we said the low number of hours is 0, so I need to find where X is 0. So in this column, if I rent the bike for 0 hours, I know it's going to cost me $0. So that's the low cost. All right, so now we need to find the maximum that it could cost us. Well, it's going to cost us the most if we rent it the longest. Well, the longest we can rent it is 5 hours. So if I rent it for 5 hours, it's going to cost me $40. So I know it can cost me anywhere from 0 to 40. Since it's range, let's go ahead and put our C in the middle. Put your 2 less than symbols. That was an ugly C. All right, so if I rent it for 0 hours exactly, I know it's going to cost me $0 exactly. If I rent it for 5 hours exactly, it's going to cost me $40 exactly. So I do want to put the or equals. Last one. Okay. Joe had a summer job that pays $7 an hour, and he worked between 15 and 35 hours every week. His weekly salary can be modeled by the equation S equals 7H, where S is his weekly salary and H